Okay, welcome back. So we're talking about renaming tables. So how do you do it? Well, I'll tell you what I would do. I would create a new table with the new name. That would be pretty simple, right? And if you already had the SQL statement, you could just copy and paste it and probably just rename something. Hey, there is a way you can actually get these tables to script. Okay, for example, I can go here and tell it that I want to script this table as, and I can even have it like it's going to be a brand new create. Okay, and give it just a second. So it says, okay, it just wrote the SQL for me, okay? And so I could go in here and change this to something, like artist 2 or something, okay? So that's a way to get there. So step 1 is recreate the table with a new name. Step 2 would be copying the rows, which is pretty easy because we now have that cool insert with the bulk insert guy. Remember that? Insert into, new artist, then we'll have a select asterisk from the old artist, right? And that way it'll just pop it on in. And then after you got that, then you manually have to go through and poke around and find everything that it depends on. Bring up the dependency thing and go find it. Say, okay, well, it looks like this is going to be depending on that, and that's going to be depending on that. And so that's kind of sort of how it's done. It's a little weird to look at it from that perspective, being able to say, I have to manually go through and find all the dependencies and fix them. And then when you're finally done, you can delete the old table. Okay, so that's 4 steps. Build a new table. There's some script magic that'll help that with that step. Do the bulk insert. Go find and fix all the things. Make sure they all work. Every time you make a change to a view where you go test it out, see if it works. And you just go through that until finally you got them all. And then finally you can say delete the guy. So what about surrogate and synthetic and auto number guys like this right here? Okay, that is not going to work because if there was a gap in here, I don't know if there is a gap, but let's just take a look. Yes, there's a gap. See, we have 1, 2, 3, 4, 5, and then there's a gap. Okay, if I was to do it the way I just described here, the gap would go away, and that the artist's numbers would change. I don't want that to happen. So the other problem is when I add a column, I can use the identity keyword to make it into an auto number, synthetic, surrogate thing, but I cannot alter an existing column to add the identity keyword. So now we definitely have a problem. I want to be able to create a duplicate table and then copy from the old table to the new table, but I can't do that because normally when you would do the insert, you would ignore the identity columns, right? During an insert, those things that are auto number, you don't ever supply anything. Well, so we need another solution. And the solution is for SQL Server. It's probably different for other SQL platforms, but in SQL Server is a thing called set identity insert on, which will temporarily allow you to actually copy the identity values over because you never want to rename or renumber an identity. In theory, if the identity is being used as a primary key, you don't ever change the value of a primary key, okay, on an existing table. That's normally the way it is. So how do you do this? How do you make altering a table that has an identity? Wow, okay. You build another table. You do use the identity when you're building it. You turn on this feature called identity insert, do the copying, turn off the identity insert feature, and then blow the old table away. Then you have to go back through, like we just talked before, about finding all the references and make all the rest of the changes. Okay. So adding and dropping columns. Now we've done this. So I'm altering a table, and I'm altering a column, and I'm doing some changing whether it's null or not null, things like that. Okay, adding tables, things. This is all pretty good, but if I said not null, then I'm going to have to make dang sure that there's no places in there that are empty, right? Otherwise, this is going to fail. I can't alter the table work by altering the date created and not have something in there. Okay, so let's just assume that I want to add a column to a table that already exists. Now, we've already done this in Chapter 7, so in theory, this is just a repeat. So I'm going to pop on over here to this guy. Okay, so let me bring this guy back up. Okay, so let's say I want to alter this and I want to add an extra column in here, right? So I say, we know how to do this, right? Alter, oh, not like that. Alter table employee. Okay, and then I'm going to do add. Do I use the word column here? Add, and then I want to do, I don't know, something else. It doesn't matter what it is. I'm going to add kumquat int not null. Okay? And it says, wait a minute, you told me it couldn't be null, but you're not providing me any information. So how do you solve that? Now, before, in Chapter 7, before we had data, you could do this all day long because you didn't have any data. But now that I have data, I have to do it a different way. I have to go in here and say, I will allow it to be nulls first. So 3 steps. One is to create the table. Then I have to go put something in there. So I'm just going to do update employee set kumquat equal 12. Now I'm not using a where clause here. All right. And then I'm going to turn right back around and alter the table one more time. Alter table employee alter column kumquat int not null. Okay, so in every scenario I've talked about is 3 steps to it. You have to, like, this is identical to how we described the thing, how to add a not null column to a table that already has data, put it in there with null, put some data in there, and then go back in and tell it not null. Okay? So again, the rules are slightly different when you have data. Okay, good. All right. So one more time, there is an alternate technique for doing this using defaults, but I certainly don't recommend it, and it's not guaranteed to work everywhere. So let's just don't do that. If I ask you, like in a test question, how do you do it? I'm expecting you to tell me this. Okay, good. I'm going to alter the table one more time, and I'm going to do something else. So I'm going to say alter table employee. And I want to add, I don't know, I'm running out of wombat. Int not null default equals 12. Okay. Well, actually default 12. All right, is this going to work? Oddly enough, it does. Okay, now you can't guarantee this behavior. In SQL Server, this works only if you use a not null. If I wish to use a null one, okay, where I allow nulls, okay, like this. All right, let's try that. Okay. Well, so is it going to be 12? Is the default going to kick in? Well, no, because I told it was the default, but then I told it, you know, like, wait a minute now. Because I told it allowed nulls, so the default only works when it's not null during an update, okay? I'm sorry, during an alter. So that is an alternate technique from the one I just described. I don't particularly want you to use it because I don't want you to learn bad behavior. So I almost hesitate to show you that. Okay, so one more time. I'm trying to add a column that's null. You know, I throw in there with allowing nulls, copy the data, and then convert it back to not null. So how about dropping a column? Well, again, if that column's not being used anywhere, there's no constraints in it. For example, it's not used as a foreign key or it's not used as a primary key. Hey, blow it away. You're okay. Like, for example, here, I could probably kill the kumquat, wombat, and wombat2 columns all day long. In fact, what the heck? I'm going to do that just for the heck of it. Okay? So I'm going to do alter table, employee, drop, and then I can do more than one. I can say drop kumquat. Whoa. Only if I spell it right. Wombat. And wombat too. Okay. Ooh, drop column. I do need to tell what I'm dropping. No, I don't. Yes, I do. And boom. Okay. Ooh. Because somebody else is being used in that? Okay, I have to figure that one out. Employee is dependent on column wombat. Okay. So basically what you have to do is you have to go in and whack the dependency, whatever it is, the foreign key dependency or the whatever. Go in and whack the column and then go back and put the dependency someplace else. Okay. So on page 444, they talk about, okay, what happens if I want to change a data type from something to something else? Oh yeah, before we get there, I put a default on that wombat guy. Remember the default? That's kind of sort of like a constraint. Now, I didn't get an opportunity to change it, but it tells me what the name is, okay? And so if you don't give a default, a constraint, a name, the machine's going to make one up for you. And it's this god-awful df underscore employee underscore wombat underscore blah, 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 blah. So I would have had to have whacked that dependency. I mean, default kind of sort of is like a dependency before I could go in and whack the column. Okay, good, good. Okay, now we can go to page 440, talking about implicit conversion. So I'm going to go here and I'm going to say, you know, I don't want that to be a string anymore. So I'm going to go in here and I'm going to say alter table employee. And then I'm going to do alter column. And I'm going to say kumquat. And then let's do, it was an integer. So now I'm going to do inchar2. And I'm going to make it, I don't suppose it really matters, but I'm going to put not null. Okay, is the machine going to be able to convert between the integer and this guy? Is it going to be able to do that? Well, let's just see. Oh, man. Oh, hell, doggone it. If I could spell these demos, it'd be a heck of a lot better. Let's try that instead. And he goes, sure, no problem. I can do that. Isn't that wild? That the machine can do implicit conversion. It goes, wow, you want me to change this number to a string? No problem. What about string to numbers? Sure, no problem. All right, so let me go through and we're going to alter this table. All right, I'm going to go in here and go to the edit thing. And so these are now strings, not numbers, this guy. So I'm going to go here and type TX. Okay. And then move off of it to make sure, you know, okay. All right. So far, so good. Now, I'm going to go and do this in reverse. Alter table employee. Alter column kumquat. Go back to an integer, not null. All right, is that going to work? Well, of course not, right? You can't convert TX to a particular thing. You know, it's wrong data type for an integer. Now, my question is, what did it do? Did it convert all the ones that it could convert and then stop? Or did it do no conversion whatsoever? It's the latter. It did no conversion whatsoever. Later on, we're going to be talking about this in the next chapter a lot. It's basically called a transaction. It's a everything works or nothing works. There's never going to be a scenario where you do an alter where half of it works and half of it doesn't. That's a good thing, right? Okay, so if I ask you, can strings be converted to numbers? The answer is, well, yeah, if everything you type in there looks like a number. If you type the word hello in there, well, then no. But it could do conversions, okay? It's called explicit conversion. Now, there is another technique that's not in the book that talks about how you can do this and continue if there's an error. We'll do that after the break.